Hello everyone, welcome back. In this video we are going to learn about resistance. So let's start with the definition of resistance. Resistance is a measure of opposition to the current flow in the electric circuit. So it means resistance offers opposition to the flow of current. For example, if you have one conductor and if there is no resistance means excess of current will flow through this conductor. So due to which it can break down also. So to prevent this, we can say resistance is used to limit the current or to limit the flow of current. Resistance is used. According to Ohm's law, we have already got the relation that V is equals to IR. So from there, if I shift I to this side, this I is getting multiplied with resistance. On changing the side, it will get divided with V. So we will get V upon I is equals to R. So we have got the formula of resistance. V is equals to R is equals to V upon I. So where R is the resistance, V is potential difference and I is current. So this is the formula of resistance. So SI unit of resistance, it is ohm, OHM, and it is represented by this symbol. For example, if the resistance of any conductor, or if the resistance is 10 ohm, so we have to write it like this. So like this we represent or write resistance. So now we have already discussed about the SI unit. So let's try to define this SI unit. From this formula, we will try to define the SI unit of resistance. So whenever we define any SI unit, we have to assume this is also one units, we can say this is also 1 unit and this is also 1 unit. So we can write the resistance with SI unit we have to write, but the numerical value always we have to write as 1. So resistance I can write it will be 1 ohm, voltage potential difference it will be 1 volt, and current it will be 1 ampere, because SI unit of current is ampere, SI unit of potential difference it is volt. So that's we'll try to define this ohm. So we can see a resistance of a conductor, it is equal to 1 ohm when a constant potential difference of 1 volt it produces a current of 1 ampere. So this is the definition of 1 ohm. I'll write it also. The resistance of a conductor is 1 ohm, is said to be 1 ohm. So this is the definition of ohm we are writing, is said to be 1 ohm when a constant potential difference produces a current of 1 ampere. So any SI unit you can define with the help of its formula. See, we just have to assume that all the values in the given formula it is 1 numerical values, and units accordingly you have to take. See, when the 1 volt or 1 volt of potential difference it produces a current of 1 ampere, it means the resistance is said to be 1 ampere. So this was about resistance and its SI unit. Now we have to discuss on which factors the resistance of a conductor or resistance of any material it depends. Factors on which resistance depends. So let's discuss now. Resistance of anything or any material depends. So the first factor, if I have any conductor, this is one conductor, let us assume its length is L and its area, this is its area. Its area of cross section, it is A. So then resistance, it depends on length of the conductor, secondly it depends on area of its cross section, and it also depends on the nature of the material, whether that conductor or whether that thing is a metal or it's non-metal or it's alloy. So it depends on the nature of the material also. Let's find it out how it depends or what is the relation. So on length, resistance is directly proportional. Directly proportional means if length of the conductor increases, its resistance will also increase. On area of cross section, resistance is inversely proportional, which means if area increases, resistance decreases. So directly proportional means both the things, they will have direct relation. If one thing is increasing, the other thing will also increase. Inversely relation means, it means if one thing is increasing, the other will decrease. So now from 1 and 2, in single step we can write resistance, it is directly proportional to L upon A. See, it is directly proportional to length and it is inversely proportional to area. Now this is a constant. Oh, this is a proportionality sign, so we have to remove it. So whenever we remove a sign of proportionality, we have to write one constant of proportionality. So here we will write rho. So this rho is the constant of proportionality. So we will write resistance is equals to rho into L upon A. So this is another formula of resistance. One formula we have already done, R is equals to V upon I. So the other one is V is equals to rho. This is rho upon rho into L upon A. So because we have discussed three things, resistance, it depends on length of the conductor, then it depends on area of cross section. So this is the third thing, which is rho, and it is resistivity of a conductor. So resistance, it depends on three factors, and this resistivity, it tells us the nature of the conductor. So as we have already discussed, it depends length, area of cross section and nature. Nature means whether it's a metal, non-metal or alloy. So this resistivity will tell us. Now let's discuss how we can represent resistance in a circuit diagram. So resistance in a circuit diagram, it can be connected in series and parallel combination. So two ways we can connect resistance in a circuit diagram, which first one is series and second one is parallel combination. So let's understand both of these. This is the symbol used to represent resistance in circuit diagram. So whenever series means we are using 2 or 3 resistances in a circuit in line. See, like this the connections will be. If this is R1, this is R2, this is R3. This type of arrangement, it is known as series combination. Series combination, you can see in line all the 3 resistances we have connected. But as you have already seen in formula, V upon I is equals to R. In all the formulas, we can use only one resistance. So that's why for these 3 resistances, we have to find resultant resistance or equivalent resistance, we can say. So resultant resistance for series combination, it will be R1 plus R2 plus R3. Now let's take example. If the value of R1 it is 2 ohm, the value of R2 it is 5 ohm and the value of R3 it is 10 ohm. So the resultant resistance of this combination it will be equals to 2 ohm plus 5 ohm plus 10 ohm. So you can add and you can see it will be 2 plus 5, 7 plus 10, it will be 17 ohm. So in case of series combination, the resultant resistance it will always be more, and we have already discussed if the resistance is more, current will be less. You can see this formula again, V upon R is equals to V upon I. You can see the relationship between resistance and current. They are inversely proportional, which means if you are increasing resistance, current will be decreased. So this was about the series combination. Now let's discuss parallel combination. So parallel combination, all the resistances they will be parallel to each other. You can see this arrangement. So this you can draw. So when the resistance they are connected in this way, we can name it R1, R2, R3. It is said to be in parallel combination. You can see it's just like the parallel lines like this. And in case of parallel combination, you can see resistance or equivalent resistance or resultant resistance we can find by using this formula. 1 upon R resultant is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So let's take example. Suppose R1 is 2 ohm, R2 it is 4 ohm, R3 it is, let's say, 6 ohm. So how we will find resultant resistance? We'll keep 1 by R, this is equivalent resistance, or we can say resultant resistance, 1 upon R1. See, R1 you can write 2 plus 1 upon R2 which is 4 plus 1 upon R2 which is 6. So you have to find the LCM of 2, 4 and 6. So you can see, so same way we have to find LCM like we find. So you can see 2 into 2 is 4, 4 into 3 is 12. See, LCM is same like the way you know, same way you have to find the LCM, and the LCM of 2, 4 and 6 it is 12. So we'll divide the LCM with the denominator and multiply its answer with the numerator. So 12 divided by 2, you can divide it, so 6 will come. So 6 you have to multiply with the numerator, so you can write 6. Same way this also, 12 divided by 4 it will be 3, 3 you can write. 12 divided by 6 it will be 2, so 2 you have to multiply here. So it will be 6 plus 3 9, 9 plus 2 11. So 1 upon R equivalent is equals to 11 upon 12. See, this is not the value. You have to find the value of R, but this is the value of 1 upon R. So here always remember one step, that the R equivalent it will be equal to 12 upon 11. So you have to do the reciprocal at the end, because this value you have found for 1 upon R and you need the value of R. So R will be 12 upon 11. Now let's discuss one more example of series and parallel combination. So now I have 4 resistances. You can see 4 ohm, 12 ohm, 8 ohm, 12 ohm and 24 ohm. So let's name these as R1, R2, R3 and R4. So first of all we'll find the resultant resistance for series combination. So RS we will write. So this is for series we are doing. So series, as we have discussed, it will be R1 plus R2 plus R3 plus R4. So we can write directly R1 is 4 plus R2 8, R3 12 plus R4 which is 24. Now we can add 4 plus 8 12, 12 plus 12, 24, and 24 plus 24 you will get 48. So you have to write 48 ohm. Now this was for the, here we will write, because we will compare also. So this is the resultant resistance for series combination. So we got RS equals to 48 ohm. Now let's find for parallel combination. So 1 upon Rp, because we are finding for parallel combination, so it will be 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus 1 upon R4. As we have already discussed, resultant resistance in case of parallel combination, it is like this. So 1 upon Rp, it will be equals to, we'll just fill the values, 4 plus 1 upon 8 plus 1 upon 12 plus 1 upon 24. Now if you find the LCM, you will get, see LCM same way you have to find, like we have discussed in the previous part also. So like you are doing in maths also, so same way, if you find the LCM, you will get 24 as your LCM. So 24 each you have to divide with the denominator. So 24 divided by 4, it will be 6, because 6 4s are 24, and then that answer you have to multiply with the numerator. 24 divided by 8, you will get 3. That 3 you have to multiply with the numerator. 24 divided by 12, it will be 2. 2 you have to multiply with the numerator. 24 divided by 24, it will be 1. You have to divide it with the, multiply it with the numerator. 1 into 6 will 6. 1 into 3 is 3. 1 into 2, 2 plus 1. You can add these now. 6 plus 3, it is 9. 9 plus 2, 11. 11 plus 1, 12. So 1 upon Rp is equals to 12 upon 24. Here we can see if any cancellation is possible, we can do. So 12 into 1 is 12. 12 into 2 is 24. So we got 1 upon Rp is equals to 1 upon 2. See, this is the value of 1 upon Rp. We need the value of resultant resistance. So we just have to reciprocal it, or you can cross multiply this R. If you shift it this side, so it will be multiplied with 1, or directly you can reciprocal it. If you want, you can multiply also 2 into 1, or 1 is equals to 1 into resultant resistance. See, this I have shifted to this side, this I have shifted to this side. This way also you can do. If you want direct reciprocal also you can do. So I got resistance of parallel combination equals to 2 ohm. Can you compare now? In series we got 48 ohm, but in case of parallel combination we got 2 ohm. So from here we can conclude that in series combination resultant resistance, it will be too high. If resistance is too high, current will be, I will be less. It will be too less. Then in case resistance is very less, less resistance means current will be more. So whenever if you see any question in which case resistance will be more, so in series combination resistance will be more as compared to the resistance in parallel combination. So this was all about resistance. I hope you have liked the concept and you have understood also. Do like, do subscribe. Thank you so much for watching the video.